in the previous class of the physics for standard 10th, we had understood the different kinds of energy from the work energy power chapter, and we had discussed that what is kinetic energy, what is potential energy, what are the different kinds of energy which are there, which from the kinetic energy can be converted into, and the conversion of one energy into another energy. The next we also saw the work energy theorem, and also the relationship between the momentum and the kinetic energy. So that was the things what we did. So now we move to the next part, and that is the numericals of this particular chapter. So this video and then maybe even the next one will be about the numericals of the work energy power, the second part of the, that is different forms of energy. So there are around 23 numericals over here, so we'll just go through them one by one. Before that, let us note down all the formulas which are connected to this particular kind of sums. So first one is, write the formula. First one, of course, potential energy is equals to mgh. Second one, kinetic energy Ke is equals to half mv square, right? The third thing will be the relationship between the potential energy and the momentum. That will be P is equals to square root of 2mk, or we can also have K is equals to P square upon 2m, right? The fifth one is the work energy work energy theorem. So the work energy theorem will be given by W, that is work is equals to half mv square minus half mu square, which is nothing but half mv square minus u square. So that is W over here. Apart from that, I don't think we will be having any other formula to be used, or maybe if we are using it, will be only for the work, or for force is equals to m into g or m into a, or work is equals to f into s. So that we can always see, because that's already done earlier in the previous lectures or previous classes. So yeah, we'll start directly with the numericals, right? So you need to note these down, right? We'll start with the sum number 1. Two bodies of equal masses are placed at height h and h2h. Find the ratio of the gravitational potential energy. So what we have got over here is that the m1 is equals to m, m2 is equals to m, because the masses are equal. The h1 is equals to h, whereas h2 is equals to 2h. See, this is always, whenever they have given you a question, compare the kinetic energy or potential energy and thing, it is always better to take the formula as ratio itself. So you will be having over here u1 upon u2, because u is the potential energy, is equals to m1gh1 upon m2gh2, wherein you now put the values. m1 is m, g is going to be g, and h1 is h, m, g and 2h. So that cancels the mm, gg and hh. So the ratio will be 1:2. So u1 is to u2 will be 1:2. Is it clear? So that is how we write the first one. The next one is, find the gravitational potential energy of 1 kg mass kept at a height of 5 meters above the ground if g is something. So that's a direct question again of potential energy. So we have the first thing, we are given the mass is equals to 1 kg. We are given the g as 10 meter per second square, and we are given the h as it is how much? It is 5 meters above the ground, so 5 meters. So accordingly we have u is equals to mgh, that is 1 into, now it is in kg, so no problems at all, meters, so everything, no need to change any of the variables, any of the physical quantities into its SI unit or something. It's already in the SI unit. G is 10 and this is 5, that is 50 joule. So that will be 50 joule as answer for the second question. We move forward to sum number 3. A box of weight 150 kgf has the gravitational potential energy stored in it is equal to 14700 joule. So they are given us that U is equal to 14700 joule. They are given the mass is equal to 150 kgf. Okay, it is 150 kgf is the mass, and the G is 9.8. G is equal to 9.8 Newton per kg. And finally we need to find out the H in the case. So we need to find out the height of the body. So we have over here that U is equal to mgh. So 14700 is equal to 150 into 9.8 into h. So 14700 upon 15, 150 of, we can make it this way, 15 into 98 is equal to h. Okay. Now if you do the calculations, we come to know that this also comes out to be 147. You can just check it. 98 into 15 is 147. You check it. 5, it's a 40, 45 plus 4, 49, 0, 8, 9. So 0, 7, 1, 1, 5, 7, 147. So this is nothing but 14700 upon 1470 is equal to h. Therefore, h is equal to 10 meters. Okay, so this is the question number 3. Now we move on to question number 4. Question 4. A body of mass 5 kg falls from a height of 10 meters to 4 meters. So mass is given to you as 5 kg. They are given that h1 was 4 meters, h2 is equal to 10 meters. So it is it is ulta. h1 is 10 and h2 is 4 meters. Calculate the loss of the potential energy of the body and the total energy of the body. So you can see G is equal to 10 meter per second square. So first is the loss in potential energy of the body and the total energy possessed by the body at any instance. So first of all is the loss in potential energy. Loss in potential energy is equal to mgh1 minus mgh2, which is nothing but mgh1 minus h2. M is 5 into 10 into 10 minus 4, that is 50 into 6 is 300 joule. Okay, so it was 300 joule is the loss in potential energy. Now the next question is the total energy possessed. Now total energy possessed will be the potential energy when it was at the initial position. So total energy is equals to original potential energy. So that is U is equals to mgh is equals to 5 into 10 into 10, that is 500 joule. So the original energy, that is the total energy possessed by the body at any instant will be 500, because then whenever it is falling or anything happening, it is just the original potential energy which is going to be the total energy possessed by the body at any instance. तो जब ये 10 से नीचे गिर रहा था, बीच में या last में या even if it is at that time also, the total energy possessed by that particular body will be the original potential energy. So you can see the total energy is the original potential energy. This is very, very important to be understood, that the total energy at any instant, okay, this total energy at any instant is equal to the original potential energy. So that gives us as 500 joules. So we move forward to sum number 5. Calculate the height through which a body of mass 0.5 kg is lifted if the energy spent in doing is 1 joule. Take G as 10 meter per second. So we have got the data here. So let's write the data first. Calculate the height. So we know that it is mass is given to you as 0.5 kg. G is given as 10 meter per second square. And the energy U, that is potential energy, or the energy spent in doing so, is 1.0 joule. So we get U is equals to mgh. 1 is equals to 0.5 into 10 into h. So 1 is equals to 5 into h, where h is equals to 1 upon 5. That is nothing but 0.2 meters. So the height will be 0.2 meters. You can see they are very easy sums. It is just based on the simple formula of potential energy is equals to mgh. You do not have anything specific in this particular thing. So let's see that you're not making silly mistakes and just not being so scared of the numericals in this chapter. Every time when we solve any sum, the most important thing is to understand the data. If you understand the data properly, then there is no problem solving those questions. If you have a problem understanding the data, only then you will face problems in doing that sums. So always see to it that you read the sum properly and you understand what is given to you, and then we can find out what is to be found. Okay, sixth question, a boy weighing 25 kgf. So the first thing what we have is boy is weighing 25 kgf. That's the mass. Climbs up from first floor at a height of 3 meters above the ground floor. That is h1 is equals to 3 meters above the ground floor. To the third floor at a height of 9 meters. So they are given that h2 is equals to 9 meters. Right? What will be the increase in the gravitational potential energy when G is equals to 10 Newton per kg? So it's very simple, that increase in potential energy is equals to mgh2 minus mgh1, which is mgh2 minus h1, which is 25 into 10 into 9 minus 3. So it's 250 into 6, that is 1500 joule. So that's the answer. 1500 joule will be the increase in the kinetic potential energy of the body when it is taken from the first floor to the third floor. So the difference in the height over here was to be taken up because at 3 meters it was already there, so we cannot take directly 9 meters. It is from 3 to 9. Question number 7. A vessel containing 50 kg of water is placed at a height of 15 meters above the ground. So we have got over here that the mass of the vessel is, mass of the water is 50 kg F, and kg, what F is not required, and the height is equals to 15 meters. Okay. Assuming the gravitational potential energy at the ground to be 0, what will be the potential energy of the water in the vessel? So that is just a simple question. So you have over here potential energy U is equals to mgh, which is 50 into 15 into 10. That is 15 5 is 75, and then 00 joule. So that is 5500 joule will be the potential energy. That is assuming the gravity. What will be the potential energy of the water? The potential energy will be equal to, so U will be equal to 7500 joule. We now move on to sum number 8. Question number 8. A man of mass 50 kg climbs up a ladder of height 10 meters. Calculate the work done by the man and the increase in his potential energy. Okay, the first one is you need to know the data. Accordingly, we have mass is equals to 50 kg, G is equals to 9.8 meter per second square, H is equals to 10 meters. Okay. You have to calculate the work done. So work done, work is equals to mgh again, because work done is nothing but mgh. We had learned it earlier in the first part of the chapter. So you can see work done is equals to 50 into 9.8 into 10. So that will give you 4900 joule. 98 into 5 is 4900 joule. Now at the same time, what is the increase in potential energy? Increase in energy is nothing but the work done. So again, increase in potential energy also mgh, therefore is equals to 50 into 9.8 into 10 is equals to 4900 joule. So that's the two answers being 4900 joule. Okay, so that was sum number 8. We now move on to sum number 9. Sum number 9. A block A weighing 100 Newton is pulled up a slope of length 5 meters by means of a constant force 100 Newton as illustrated. What is the work done by the force F in moving the block A 5 meters along the slope? So first thing is that, okay, what we have is like this. This is the mass, and this mass A, this is A, object A, and the force is given this way, F, and it is traveling up to this point over here. This is A, vector distance of 5 meters, okay, and this height over here is 3 meters. The first thing what they are, so what they are given us that mass is equals to 100 Newton, okay, and the length of the slope, so S is equals to 5 meters. So this is not mass, it is the force, it is 100 Newton. And so first of all they asked the work done, so W is equals to F into S, because it is in line with the force. What is the first question? What is the work done by the force in moving the block A 5 meters along the slope? So we are not taking into consideration the angle. We are just taking into consideration that along the slope, if I am taking it 5 meters, then what is the work done? So the work done is equal to F into S will be equal to 100 into 5. The angle we are not taking over here for two reasons, because they have not asked us the actual displacement. It is not from here to here the displacement. Okay, the displacement is in line with the, so force is in line with the, see the force is not towards the ground, it is in line with the slope. So it is whether if the slope, if the force and the displacement are in the same line, you are just taking F into S. Did you understand this? If the force and the displacement are in the same line, then no theta is required. Theta will be required only if the force is in one direction and the displacement is in the other direction, right? So don't confuse yourself in this particular manner. Yeah, so this is nothing but 500 joule. So that's the first part. The work done is 500 joule. The second part, what is the increase in the potential energy? Now the increase in potential energy is the difference in the height from the ground level to this level. That is 3 meters given to you. So you can see the increase in potential energy is equals to mgh, where h is nothing but 3 meters. So this is the h we have taken over here. So we can say h is equals to 3 meters. Accordingly, we have mgh. Now m into g is already given, so it will be f into h. So that is nothing but 100 into 3 is equals to 300 joule. So 300 joule will be the increase in the potential energy of the body. And finally again account for the difference in the work done by the force and the increase in the potential energy of the block. So what is the thing? When I pushed it, the amount of work done by me is 500 joule, but the amount of potential energy which the body achieved was only 300. So what will happen? There is a loss of energy by, so there is a loss of energy is equals to 500 minus 300 is equals to 200 joule, which is used up in overcoming the friction. Right, there is definitely going to be a friction because it is in a slopy area. So when you are pushing it, there will be a friction which is trying to pull it downwards. The gravitational pull and the friction is going to pull it downwards. So that is why we are saying that the energy, that is 200 joule, is used in doing work against the friction between the block and the slope, which will appear as heat energy also. So that's why I say this 200 joule used up to overcome friction between body and the slope. Okay, so this is what and which will be converted, or you can, it will appear as heat energy. So of course energy can neither be generated, created nor be destroyed. So ये 200 joule गया कहाँ पे, right? If we are saying that 200 joule of energy is lost, so it is not lost, it is just going degraded. If you remember, we had learned degradation of energy. Bulb चालू हुआ था तो bulb heat भी हुआ, तो heat तो मुझे नहीं चाहिए था, but heating was a part and parcel of burning the bulb. So bulb gave me light, but at the same time it got heated also. Similarly here, when the loss is there, this loss is going to be in form of some other energy. So that energy, what will be there, will be in the form of heat, because when it is being pushing upwards, at that time there is a friction between the body and the slope, and due to that friction there will be heat generated on the body, which will be equal to approximately 200 joule. So that was sum number 9. We now move on to sum number 10. Now, I think this up to sum number 9 was related to the potential energy. Now, after sum number 9, the 10th one is related to kinetic energy. So, we'll be using the formula for kinetic energy now. Find the kinetic energy of the body of mass 1 kg moving with a uniform velocity of 10 meter per second. So, we have over here that the mass is equals to given as 1 kg and the velocity v is given as 10 meter per second. So accordingly we have Ke is equals to half mv square. So that's half into 1 into 10 into 10. So that gives you as 50 joule. So 50 joule is the kinetic energy K, kinetic energy of this particular body. So K or Ke, I'll put it, we can see it's already only K. So K is equals to half mv square is equal to 50 joule. Next is, if the speed of the car is halved, how does its kinetic energy change? Okay, the question is a relative question. So they are given that if the speed is halved, then what will be the kinetic energy of that particular body? So again, because we are comparing the kinetic energy between the two, so let us do something like a ratio. So we have over here the 11th question as the mass m1 is equals to m, m2 is equals to m, v1 is equals to 2v and v2 is equals to v. Because it is given that it is half, so it's better that I take the initial velocity to be 2v, so that half will be v. So I'm not taking any fractions. See, fractions क्या, fraction के fraction में फिर ऊपर नीचे करना जरा तकलीफ होता है, तो उसके बदले better है that you use 2v as the initial velocity and the final velocity to be v. So accordingly we have that k1 upon k2 is equals to half m1 v1 square upon half m2 v2 square. So this will be equal to half of getting cancelled. the m1 is m, v1 is 2v the whole square upon m into v the whole square. Mm gets cancelled, we get over here 4v square upon v square. So accordingly, k1 upon k2 is this way, 4:1. So what has happened? You are asked what is the decrease in the, what will be the change in the kinetic energy. So you need to find out the value of k2. So what is k2 over here? K2 is equals to k1 upon 4, or we can say it's 1/4 the original kinetic energy. K2 when it goes here and 4 comes here, it will be k1 upon 4. So it is 1/4 of the original value. So the value will become 1/4. We now move on to sum number 12. Sum number 12. Calculate the decrease in the kinetic energy of a moving body if the velocity reduces to half of the initial gap. So exactly the same thing. So let's do it this way, that we'll write the same thing over here but in a shortcut manner. So k1 upon k2 is equals to half m1 v1 square upon half m2 v2 square. Half of cancel, m into 2v the whole square upon m into v the whole square is nothing but 4v square upon v square, that's equal to 4. So k1 upon k2 is 4. Therefore k2 is equals to 1/4 k1. Now, so what is the change? Now what they asked us is the change. So what is the change over here? So change is equals to k2 minus k1, or k1 minus k2, because this is smaller. So that will be k1 is k1 and k2 is 1/4 k1. We can see that k2 is 1/4 k1. So it is k1 minus 1/4 k1, which is nothing but 4 k1 minus k1 upon 4. So that is 3/4 k1. So that is change. Change is equals to 3/4 of the original. Okay, 3/4 of, so 3/4 of initial. Got it? So that was sum number 12. We now move on to sum number 13. Two bodies of equal masses are moving with the velocity, uniform velocity v and v2. Find the ratio of the energies. Again the same sum. So I don't know why they are asking such sum. So it is m1 is equals to m, m2 is equals to m, v1 is equals to, they given initially was v, and v2 is equals to 2v. So k1 upon k2 is equals to half m1 v1 the whole square upon half m2 v2 the whole square. So that gives me as m into v square upon m into 2v the whole square. So mm cancels, v square upon 4v square. So that's why k1 upon k2 is equals to 1/4 is equals to 1:4. That's the ratio. Okay, so that was sum number 13. I think we'll continue with the sum number 14 in the next video.